Imagine the scariest thing that could ever happen in outer space. Floating alone? Losing oxygen? Drifting forever? Nope. The real nightmare is falling into a black hole, a place with no bottom, no escape, no return, and no guarantee that the laws of physics will still apply. Here's the insane part. As you fall toward one, time slows down. Space warps around you, light bends in impossible directions, and eventually your entire body is stretched like cosmic spaghetti. Meanwhile, to anyone watching from the outside, you don't plunge in, you simply freeze in place and fade away. Yeah, falling into a black hole is way stranger than any sci-fi movie has ever shown. So, let's walk through exactly what would happen if you fell into one. Buckle up. This gets weird fast. A black hole isn't an actual hole. It's a region of space where gravity is so strong that not even light can escape. Escaping Earth requires a rocket traveling at about 40,000 kilometers per hour. Escaping a black hole would require you to go faster than light, something nature simply does not allow. Black holes form when giant stars collapse, packing millions of times the sun's mass into a point smaller than a grain of sand. The edge around this region is the event horizon, the point of no return. Once you cross it, you're gone forever. Approaching a black hole, everything feels normal at first, but as you get closer, reality starts behaving strangely. Time dilation kicks in. For you, your clock ticks normally, but for anyone watching, your time begins slowing down. On the International Space Station, astronauts age only a few milliseconds slower than people on Earth. But near a black hole, your 1 minute could be someone else's 100 years. Closer still, the light around you begins to warp. Gravitational lensing bends starlight so aggressively that the universe appears distorted and twisted. You might see stars loop around you, your own reflection stretching across space, or the sky folding in on itself like a cosmic kaleidoscope. Then you reach the event horizon, and the strangest thing happens. Nothing. No explosion, no sudden tug, nothing dramatic. You simply drift through an invisible boundary without noticing. But to people watching from a safe distance, you slow down, glow red, fade to black, and freeze right on the horizon. Forever. It's as if time stops for you at the edge. But inside the event horizon, escape becomes impossible. Every direction, every possible movement, every future leads inward toward one place, the singularity. You can't turn around, you can't hold on to anything, you can only fall deeper. And then comes spaghettification, a very real phenomenon. Gravity at your feet becomes massively stronger than gravity at your head. The difference stretches your body brutally. You become longer, thinner, pulled apart atom by atom. Your cells stretch like rubber bands, your molecules tear, your atoms rip into a long stream of matter. In smaller black holes, this happens instantly. In supermassive ones, you might fall for hours before being torn apart. Either way, your body turns into a cosmic noodle. As you fall deeper, space and time begin to switch roles. Moving toward the singularity becomes as unavoidable as moving forward in time. No matter where you try to go, every path curves downward. Space collapses around you, and the flow of time twists into something unrecognizable. Eventually, you reach the singularity, a place of infinite density and infinite curvature of space-time. You don't hit a surface. There is no surface. Instead, your remaining particles are crushed into pure energy. Einstein's E=mc² plays out in its most extreme and violent form. Matter becomes energy, information gets scrambled, and physical laws stop making sense. But here's the mind-bending part. Some scientists believe you might not completely die in the traditional sense. One theory suggests black holes create baby universes, and falling into one could mean your information lives on somewhere else. Another idea says that inside the black hole, time points in a new direction we can't understand, meaning existence might continue, just not in our universe. And Stephen Hawking's information paradox proposes that the details of your existence might be encoded on the event horizon like a cosmic hard drive, not destroyed, but transformed. If you throw a clock into a black hole, the clock next to the object would tick normally. But to an outside observer, it slows down, slower and slower until it appears frozen forever at the edge. This is why people say black holes don't just swallow matter, they swallow the future. As for Earth falling into a black hole, good news, the nearest one is about 1,600 light years away, so it's not happening. But hypothetically, the atmosphere would rip away first, oceans would boil, continents tear apart, and the whole planet would stretch into a glowing ribbon of plasma long before reaching the event horizon. A black hole isn't just an object, it's a boundary, a place where the universe tells us, your physics ends here. Falling into one isn't just falling, it's crossing into the deepest and strangest mystery in existence, where time stops, matter shreds, and reality itself breaks apart. If you want more mind-bending topics like wormholes, faster-than-light travel, parallel universes, or the real physics of time travel, just say the word. The universe isn't just big, it's far stranger than anything we've imagined.